Hey guys, welcome back to our video series on our advanced overview of monopoly. In this video, we're going to go into the details of first degree price discrimination. Let's go. When analyzing first degree price discrimination, it's better to first consider its implications for the case of a market with a single consumer and then generalize. This makes things both conceptually and computationally simpler. The profit maximization problem for our monopolist is the following, where he must choose to maximize his profit function subject to this constraint here. In this case, the monopolist wants to offer the consumer a optimal price and output combination R star and X star that gives maximum profits to the monopolists. We see that R star is here alone because the monopolist is selling a single bundle embodied by this price, because by first degree price discrimination, you're giving a whole unique price for each unit. So R here is on its own. R star is referred to as the take it or leave it price, where the consumer can pay R star to consume X star, or they can choose to consume nothing. By the nature of our constraint, we want R to be as large as possible, so that way profits are maximized. So using this constraint and subbing it into our objective function, we now have an unconstrained optimization problem, and we can take our first order condition. From here we go and we see that our marginal utility from consumption of good X is equal to C. So this is a maximum value, right? At this optimal value, this is where the take it or leave it price is R star is equal to X star. So due to the nature of our maximization problem and the profit function, our producer captures all our consumer surplus in this case. So there are a couple features of first degree price discrimination that are worth noting. Firstly, production under first degree price discrimination is Pareto efficient because we have a case where marginal cost is equal to marginal benefit. Secondly, the monopolist is producing in the same way as it would in a competitive industry. However, the prices for our consumers are going to be different, right? Thirdly, this is the same outcome if a monopolist would charge a different price for each unit of output our consumer demands, meaning that there's going to be one price for the first unit, a second price for a second unit, a third price for a third unit, right? As in, they're just going and stacking on top of each other. A mathematical property of first degree price discrimination is the following. Given that we have this normalization around where u of x evaluated as 0 is going to be equal to 0, we can say that for a monopolist doing first degree price discrimination, we have the following situation, which is the summation of all prices of each individual unit is going to be embodied by this utility function. Practically speaking, this is the sum of the prices for marginal willingness to pay, right? Noting the fact that our marginal utility from consumption of good X is equal to price. That's an optimality condition. At each unit is equal to the total willingness to pay, right? This is communicated by our utility function. So that's our overview of first degree price discrimination. In the next video, we're going to talk about second degree price discrimination. I will see you there.